Hey everyone. Hi. So I'm Tiffany West, and I head up the authoring tools group at Unity Labs, and I'm very excited today to introduce Nathaniel Dirksen, who is the digital supervisor at Baobab Studios. I'm sure all of you have heard about Baobab before. They're doing some of the best work, I think, right now in VR animation, really pushing the envelope to achieve what we can do in 2D, in 3D, and VR. So with that, I'll let him take it away, and then I'll come back on and we'll do a fireside chat in a bit.
Cool. Well, thanks, Timothy. I'm really happy to get the opportunity to talk to you today about all of our work and some of the learnings we've had. Unity has been actually a really big part of our success, and so it's really fun to get to come here and share some of it with all of you. At Baobab, we're really trying to sort of almost reinvent traditional animated narrative storytelling using virtual reality. And our approach has always been really sort of story first and to really focus on the narrative, telling compelling stories. And like Eric Darnell, one of our founders and chief creative officer, he was the director and writer of all the DreamWorks Madagascar movies. And so the challenge is really to try and bring that same quality of storytelling and hopefully visuals and engagement to a real-time engine, where instead of watching the story unfold in front of you on a screen, right? The viewer is actually immersed in the animated story. So far we've had sort of 3 major projects. First we had Invasion up there on the left, where our cute, adorable bunny fights off aliens coming to conquer the Earth. And then in Asteroids, we sort of dive in and learn more about what those aliens are like. But now finally, we're currently sort of working on Rainbow Crow. So Rainbow Crow is a story based around a Native American myth. And as I was saying, as I started, story is very important, but we're also always looking to push the envelope in other ways too, because with every project we want to get better and do new things and sort of refine our ability to tell good stories. And so with Rainbow Crow, one of the things that we really wanted to focus on was putting the viewer into this storybook world, right? We didn't want it to just look like a normal CG film, but we really wanted to sort of give the viewer the feeling that they'd really stepped into this storybook. So I expect a lot of you haven't gotten to see Rainbow Crow at all, so I thought I'd show you just a little clip from the opening so that we're all on the same page to start with. This is somewhat a work in progress. It's from our Rainbow Crow preview that showed at Tribeca this year, but it's probably a little different from what the final piece will ultimately look like. Here you go.
Wait! I think I smell something. Do you smell something?
I don't know. Maybe. Oh, yes. Yes. Oh,
Any luck?
No. Nothing over here.
Hey, what are you doing?
Nothing.
Why, you little...
Wait. Easy. Come on, Mickey. Leave some for me.
Yeah, right. Like you were gonna.
Hey, who's your amigo? Eh? Thank you.
Oh my gosh. This is so good. Sorry.
So you note the distract lack of crows there, but I promise Rainbow Crow does have a crow in it somewhere. In trying to sort of achieve a VR storybook look, there's sort of 3 major topics that I wanted to talk about today. So one was theatrical lighting. We wanted to sort of look at lighting techniques that could really emphasize the world in a really interesting fashion and help the viewer see understand where to look. We also are going to talk about sort of creating real softness with noise, right, and trying to break away from that sort of classic CG look and get to something softer. And then to really be immersed into this world in VR, we also need to give the users a sense of presence where they really feel like they're in the world as opposed to just watching it. And so we'll talk a little bit about that. But to start off with, I thought we should talk about some of the theatrical lighting techniques that we used. And so first off, here's some early concept work from Rainbow Crow. And so you can see, in contrast with like Invasion or Asteroids or sort of more typical CG fare, it's a really sort of different look, right? There's a lot of these very simple shapes, but it's very stylized. And it's definitely sort of very sort of textured and painted. But it's also a place where we're starting to explore sort of like what the lighting might look like, right? And sort of with this light coming in from the side to sort of set the stage for the skunk to perform on. And that really sort of keyed in us an idea that we wanted to pursue further, right? Because not only like does this create like a really like dynamic, like interesting like lighting scenario to like watch the piece in, but it can also help solve a problem in VR. Because in VR, it's really hard to get the user to like focus on what you want when you're telling a story, right? Like you need them to be paying attention to like where the action's happening, but they have the headset on, they could be looking anywhere, right? And so sort of by using some of these theatrical lighting techniques, we can also help guide them so they see the story and follow it well. So I'm always a little bit tickled that we're sort of bringing all of these like old sort of theatrical lighting techniques that have been used for hundreds of years, and then like bringing it to this new medium of VR, right, where we're lighting the world around the user. But really, we're sort of just trying to leverage and steal from as much of some of the theater techniques as we could. So when we started exploring this in VR, we were not in VR, but sort of in our concept art, it looked something like this, right? And I think it's a pretty cool image. Like it's definitely, you have this sort of light sort of highlighting this tiny area of the scene, and everything falls off to darkness all around you. And it's definitely dynamic and cool to look at. But it's also a little dark and foreboding. And you're just seeing it up here on the screen, but imagine yourself sort of in this VR environment with this beautiful lit thing around you, or in front of you, but then it just sort of falling off to mysterious darkness all around. And it was a little scary and foreboding, we sort of felt like, for kind of the happy, fun story that we wanted to tell. And so, but I think it still showed a lot of promise. And so we kept sort of iterating on the concept. And we came up with something sort of more like this, where we still have this dark environment around you, but it's illuminated from beyond, right? We've added this horizon light so that you feel like you're in this lit, illuminated world, and maybe you're in a forest where it's a little dark around you, but you're still in sort of a happy place. So this is sort of our initial, lighting setup, like the art that sort of drove what that initial lighting setup should be like. But as I was describing, we also want to be able to like bring on some key light and add some like color and life to the scene, and add like an area of attention where we'd want sort of the users to be focused and where sort of the action can all unfold. And we actually want several different scenarios like this, right? Where as the characters move around, we can light different areas to really draw attention to them. But it actually gets trickier than this too, because in the story of Rainbow Crow, we have to transition from this beautiful like lit environment to like a cold, harsh, snowy landscape. And so within the same scene, we need to transition between all of these sort of lighting situations, right? From sort of dark to different key lights coming on, and eventually the icy winter. And so obviously we want to do as little work as possible. So we were trying to figure out what solutions that we could do just using sort of the existing Unity framework. And the easiest thing in a lot of ways is just to like have static lights and bake everything. But at least out of the box, there's not great support for like blending between all these lighting scenarios. So it didn't work great for us. And there was also some discussion of trying to do it like dynamic lights and simulating the bounce all in real time. But especially rendering for VR, where you have like to render at 90 frames a second to 2 eyes, there's just like no way that we could do this with 1 or 2 real-time lights, and that's really all we could afford. And in real-time GI seemed like it had a lot of potential, and so we played around with it for a little bit. But at least in our experience, we had a lot of trouble getting like really art-directable results. So we could get something that looked pretty good pretty fast, but then to really get our art directors like creative vision for exactly like where all the light and shadow should play, we didn't feel like we had quite precise enough control for sort of the level of art direction that we wanted. And so what we ended up doing was moving more back towards the static lighting approach, but sort of what we called light state blending, where we'd actually bake out each of the lighting states that would exist. So like that dark scene, the different key lights that could turn on, the winter scene. And we would bake those out sort of like normal. And then sort of using custom shaders, we would blend the results between those states, right? And we blend everything. We blend the light maps, the reflection probes, the light probes. We could blend it all together so that we could sort of dynamically change the lighting environment in the scene. And that was extra great because we could apply all the controls via timeline then, right? And so we use timeline a lot to sort of plan out sort of our narrative actions, the animations that are taking place. But this lets us time the lighting changes with sort of the same degree of finesse and the same ability to just sort of drag boxes around the timeline. So that was really actually super useful. And it was also great that because it was essentially all baked, there's very little runtime cost. So performance-wise, it worked really well. And so let me just show you sort of what one of those blends looks like. So I'll just play it here. And so you can see that as the skunk comes on there, we sort of can blend on that key light. And this really just transitioning between two static lighting scenarios, essentially. And so there was a lot of good parts about this, like I was just saying, tons of creative control, and you can have essentially an infinite number of lights because they're all, for the most part, baked, with a couple real-time ones for shadows and stuff. And because it was a relatively simple approach, it was actually really quick to get going and to get our basic prototype up and running to make sure that it worked. But I wouldn't necessarily claim this is like the be-all, end-all solution, because there are certainly problems with it too. The iterations can be slow, like when you're not working with real-time lights and have to bake everything, like that baking process can slow you down. And like geometry changes or UV changes were extra expensive, right? Because you're not just baking once, but you're baking for every lighting scenario that you have set up. And so I think we managed to cut it down to like 7 scenarios, but that still means if you want to like change the UVs on a bush, you're like doing 7 light bakes. And so, even though the prototype was very quick to stand up, there was a lot of development that went on top of that to make sure that like the process was at least relatively smooth for our lighting team. And finally, this is ultimately still all baked in a sense, right? So even though we can transition between these sort of pre-established lighting environments, if you had something interactive, right, like if the user was carrying a candle around, right, like you couldn't respond to that the same way. But at least for our situation here, where we do not have a skunk or a moth carrying a candle, it worked really well. So yeah, then I want to move on to talking about our technique for trying to achieve some softness and real texture to our environment and our characters. So here's another piece of concept art from early on in the process, and it shows this look that we really fell in love with this like really textured appearance to everything in the environment, and this real sort of soft fall off around all the geometry, right? Like you don't see these super hard, crisp edges, but everything just sort of is fading off to transparency, and like those bushes have like a lot of internal detail and texture to them. And so we really wanted to achieve something like this that didn't feel sort of like classic CG, but felt like really like interesting and textured. And so that's really the look that we were going for. And to sort of go back to our key art piece here, it's been dialed back a little bit from that first piece of concept art, but it's still absolutely in there, and all the bushes and the trees and the rocks. And it's actually really important for creating like visual interest in this scene, right? Like those bushes are just like spheres essentially, right? And what's adding interest to them is that transparency fall off and all the textures. Because like if I were just to take this and just bring in this geometry, it would kind of look like that, right? And that sucks. That's not at all what we want, right? So when we first sort of modeled the scene and it looks like this, we knew we were going to need to do something to try and get back to that look of softness. And so one easy solution just be to add fur to everything, right? We could put fur on the trees, on the ground, and on the skunk. Well, even this doesn't look that great when it comes down to it. But also this is ridiculous, right? Like if we're trying to render at 90 frames per second, 2 eyes. There's just no way that we are going to successfully push this much fur through in any sensible fashion, right? So yeah, no fur. So instead, what we did was we looked at this art, and we really, like, when our art director was making it, right, it has this beautiful sort of like stippling sort of point, pattern. And we really decided to try and like embrace that noise in terms of like how we would approach creating like softness and texture for the film. And so there's two real areas I think where or we can sort of split up into two major areas, right? So first we have like what we call like the dither. And this is sort of all that stippling or texturing that you are seeing like inside of the bush, right? Like that gives it all of that internal texture. And then, like I'd been talking about, we have these soft edges, right, where the bushes sort of fall off to transparency. And so we can talk a little bit about how we achieve both of those results. But let's start with the dither, sort of that internal detail. And so like I said, the major idea here is that we wanted to add noise sort of into the scene to try and create like a lot of this detail. But just throwing noise on can lead to some really terrible results, right? So like if you try to do something like screen space noise, at least in VR, it really feels like it's just your headset that's dirty as opposed to like actually having noise that's in the scene. And anything that's changing from frame to frame is going to look like it's buzzing, and we wanted something that wasn't like visually distracting, it was just sort of adding subtly to the world. And so yeah, anything with like buzzing or moire patterns we wanted to try and avoid. So what characteristics do we want? So we want noise that sticks to objects, right? That like if you see like this stippling pattern on a bush, as you move around the bush, we don't want to feel like that texture is moving with you, right? So we basically want spatial and temporal coherence, right? Like we want it to stay on the bush in space as you move around, and like as you move through the experience in time, we want that noise to stay constant. And we also want it to be like small scale, like pixel scale noise, right? Like as you get close to that bush, we don't want these like noise pixels to get bigger and bigger until they fill your field of view, right? Like we want to keep that sort of pixel size scale of noise sort of throughout the experience. And so here's an image of noise, very exciting. But I'm going to play this movie here, and you'll see that it's actually our dither shader applied to this geometry. And so as we're moving the camera through the scene, and initially it basically just looks like a screen full of noise, but once you sort of see it moving and you can sort of see the parallax, you can start identifying like where the bushes are, like where the trees are, and even with no textures, no materials, you can still understand what's going on. It kind of reminds me of one of those like magic eye posters where you have to cross your eyes to see all the shapes. And let me tell you, this is actually like even cooler in stereoscopic VR too, right? Because then you get like the depth cue of this like noise passing you by. But any individual frame still just looks like clean random noise though. And so this is really sort of the characteristic that we were looking for. So to achieve that, we created a shader that would like apply this noise texture based off like the screen space derivative of the UV coordinates. And that probably sounds kind of similar to map mapping because there's definitely like very similar notions to the approach, right? But instead of these like refined different levels of texture, right? We have a single noise texture, and so we can sort of, we quantize the scale, but it lets us sort of scale infinitely large or infinitely small, right? So you can get as close as you want to that surface, and you'll still just have repeating noise all the way across it, or even far away, that noise is still going to stay like pixel scale. And so that was pretty successful, I think. And so here's just sort of one more movie of it in action, sort of zooming in on this sphere to get closer and closer. And you see the noise sort of stays the same size as we move in and out. And even if we do something like rotate the sphere, you sort of still feel like that noise is attached to the sphere rather than swimming through it or something like that. So we can also leverage that dithering technique for creating our soft edges. So to really do these soft edges, we really want order-independent transparency, right? Because we don't want to have like sort of visual discontinuities from the skunk is like diving through the bushes, and we have all these different bushes layered on top of each other. So like if you look at the image here, right? Like we have many layers of bushes. The skunk is running through them and around them. But the problem with order-independent transparency, as opposed to like trying to do like based on object ordering or something, is that it's kind of expensive. I mean, oftentimes, I guess, right? But what we ended up using was this alpha to coverage feature in the shader. And I don't know how widely known this is. Like, it wasn't known to us, and it kind of worked like magic, which is pretty cool. And so it's only available on like relatively modern hardware, but like anything that VR supports, or any hardware that's going to support VR, will also support alpha to coverage. And what it does is it stores sort of the opacity layer in the MSA depth buffer. And so you get as many levels of transparency as you have like depth buffer samples. And so we wanted good transparency, so we used A samples. But then we sort of modulate that with the existing noise texture that we have from the dithering that I discussed just before. And so like here's a sphere, right, with like a fall off of our opacity, right? And you can see there's sort of this like 8 quantized levels because of the 8 levels of transparency. But then, if we apply that noise from the dither, we can actually smooth all of that out, right? And by having that noise applied on sort of top of these opacity levels, we end up with something that looks like a very smooth sphere. And so we're sort of able to leverage our look that we've sort of already established to also help us get to sort of the transparency and fall-off that we want. So for actually sort of establishing that fall-off shape inside of the geometry, it's relatively easy on primitives, and I mean, there's a great Oculus blog post, Colorites in Spaces, working with colors, that you could take a look at. It gets a little trickier with characters, right? Like with the skunk's tail that could be wrapped around her where she's holding it and all that. And I'm just going to gloss over that for now because, we could do a whole other talk on that. But, it's also very character independent though, right? So different characters, if they're a simple character who's more like a primitive in shape, you can really get away with pretty simple stuff. But let me show you the results for our skunk here. And so you can see sort of internally there's that nice, detail in the fur that makes it feel really textured, and the tail itself has that nice soft fall off on the edges so it doesn't feel overly sharp. And here's sort of that same pose like in the actual scene. So finally, I wanted to talk a little bit about presence. Part of achieving like a really successful experience in VR isn't just like creating these really beautiful visuals, but we also need to like craft the illusion that the viewer's really been like transported into this storybook world, right? Like we don't want them just to feel like an observer, but we want them to feel like they're really inside of it. And talking about presence in VR could easily be a whole talk, and it could really easily be like many whole talks. So we're not going to go over all the details here, but I thought it would still be good to show you at least like a couple of examples and things from previous projects that we've learned and are now applying on Rainbow Crow. And so one of the most useful tools, I think, for presence is creating like these really empathetic VR characters. And they accomplish it in many different ways, right? So one of the most important ways is like establishing a connection with the viewer, right? Like if the viewer like really cares about the characters, it's both really important for the narrative, but it also helps sort of bring them into the world. And if the characters even do like sort of simple things, like just acknowledging the presence of the user or the viewer, then it really makes the viewer feel like they're in the world as opposed to just this sort of like ghostly observer. And if you push that further and further, you can do things like pose mirroring, right? Where the characters even sort of subtly react to the user tilting their head or the user's like body pose, just like humans do when we're interacting with each other, right? And by sort of applying some of that same science of like subconscious communication, we can put that into our characters, right? And really help draw you into the story and draw you into the world. And we also talked about sort of the importance of directing the viewer's eye, right? And so our theatrical lighting techniques are one way to do that, but sort of a character who you sort of believe is real and is in your world, like that's another great technique, right? Just like if we're in an environment, we respond to cues of all the people around us in terms of what to do, and so we can have our characters apply those same cues. And finally, having good characters in the scene are also a really good way to give the user feedback about what they're doing, right? Like, in a lot of our experiences now, there's hand controllers and stuff. There's more to do in the scene than just look around, right? You can interact with the characters, with the world, and the characters' feedback to the user can like let them know what they're doing. So I'm going to show you just a couple of examples of what I was just talking about from Invasion, our first project. But first off, let me just show you, a short set of clips from it. So here's our little bunny. And our aliens. So I have always been a big fan of our somewhat inept alien invaders. But really, like, when we started showing this to people, like, the bunny up there, like, he just stole the show, right? And, once you get in the headset, you're not watching a movie, there's no camera, there's no screen. It's just like you and this bunny. And so when this bunny sort of hops up and just starts looking at you, it really does establish a connection, right? And it's amazing, like, how much it helped, like, the viewer sort of suspend their disbelief, right? And sort of by, like, suspending their disbelief, like, really, like, bring them into the world, right? And, you'd see people, like, reaching out to pet the bunny or, like talk to it. And just sort of this simple act of, like, hopping up to you and making eye contact, like, instantly makes you feel like you have a connection with this bunny. But like I said, we can also then, like, we don't want to just let you stare at a bunny, for, like, a 5-minute VR experience, right? So, we can have the bunny sort of help direct you to what you should be looking at next, right? And so by breaking that eye contact suddenly, like, that character is interested in something else, right? And if you believe that's, like, a real character, which hopefully you do if you're really establishing this connection, right? Then the fact that they've suddenly gone off to look at something will hopefully inspire in you, like, the same curiosity. And so even just the simple things like starting the eye contact and then breaking it can help direct you to, or direct the viewer to what they should be looking at. And so, I mean, you might ask, like, why that even matters, right? Like, because there's other techniques to make sure that the viewer's, like, looking where they should be, right? Whether you sort of go into cycles or, whatever. But, like, let the viewer sort of cue things with their clicker. But really, like, in telling story, like the pacing and the rhythm and the structure of the story is super important, right? And I mean, like, in, like, DVD bonus features, you always hear about how, like, the director and the editor worked for hours and hours, like, just trimming shots here and there to, like, really, like, get the movie into, like, a great shape. And, the same thing really applies to, like all sorts of storytelling, right? Like editors and books, and, like, it's true in VR too, right? And so, like, we do want to control the pace of the story because, like real life doesn't wait for you, and, like, a story won't either. And so establishing cues, like the theatrical lighting, like these, characters looking and cueing things based off eye direction, they really help us, like, guide the viewer while still maintaining, like, a really good pace to the story. But it does get harder and harder, like, the more control the viewer gets, right? Like, once the viewer can, like, do more than just look around and, like, start interacting with the characters, it just ups the ante on everything, right? Because now not only do the characters need to, respond to the user in a sensible way, but still, like, get back to the story arc in not just, like, in a timing sense even that feels good. So, like, I think all this speaks to a little bit just even getting to, like, what VR storytelling is. And I think with something like film, it's pretty well understood. And it's on one end of the spectrum. It's totally passive, right? And then with video games, it's a very active storytelling medium, right? Like, you can still tell a really good story in video games, but, like, a lot of the time it's more based around, like the user doing something, the user taking actions. And so the question is, like where does VR fall? Is it sort of like this halfway in between things, like when we're telling a story? And I think that we would actually argue that it's not just, like, halfway on the spectrum, but it's actually, like, a completely new medium that lets you do completely new things. And so, like, in VR, like, I think that you do get the opportunity to have, like, a lot of the same empathy that you would have in a film. Like, you'd care about the characters and, like, their story and all that. But, like, unlike a film, but more like a game, you have agency. You can actually act in that world. But when you really, like, combine those two things, you get something totally new, right? Like, you have empathy for the characters, but then you also have the ability to, like, act on how you care for those characters. And so I think, like, you could call that almost compassion, right? Where you're performing some action because you care about the characters. And that's sort of like a feeling that you can bring about in VR that isn't really possible, like, in classic film or in sort of classic video games. So yeah, that is what I have for you today about sort of establishing that look for Rainbow Crow and what we did to sort of immerse the user in the experience. So I think we're going to move on to more of a fireside chat style thing now.
Awesome. Thank you so much. Yeah, I have some questions for you, and I think the audience will have some questions too. So I thought I would take it back to start a little bit in your history, like what you started off doing. You mentioned you were at Digital Domain after college, and then you worked at DreamWorks for 9 years. So can you talk a little bit about how you went from there into Baobab, and I guess a little bit before too?
Sure thing. So, I mean, I guess, like, my background's all in computer science. But when I graduated, like, I didn't want to just go off and be sort of a software engineer. Like, I really wanted to work on something that, like, people could see and was really, like, fun and engaging. And that's, like, what led me to visual effects. But then, you know, like, visual effects are fun and exciting, but I have always just been, like, I had this real love of animation and you know, telling animated stories and, you know, goofy, googly-eyed animated characters. Like that's just what I love, right? And so it was a fantastic experience to go to DreamWorks, right, where I was a character technical director doing a lot of character setup. But I don't know if you know the whole story of DreamWorks, but DreamWorks has had some financial difficulties over the time, and so I was up at the PDI DreamWorks studio, and ultimately that was closed. And you know, at the time it was very sad, but actually there were a ton of people from DreamWorks who went on to form all these different tech companies, and especially like in these new areas like VR and AR. And so, you know, I was a little dubious of the whole startup thing to begin with, right? Because, you know, you hear all these horror stories. But like people like Eric Darnell and Larry Cutler and Michael Hutchinson, these like people who I have tons of respect for from DreamWorks were starting up at Baobab, and I decided that I would join up too. And it's been great. Like, I've been super happy about having made that decision.
I am glad you're there too. So we talked about this a little bit before the talk, but digital supervisor, what does it mean you actually do day to day?
Oh my gosh, I have no idea. So, like, digital supervisor is sort of this slightly abstract, even vaguely made up term, I suppose. But what it really means is that like my job is to understand how we do like everything technically, especially like a big picture sense at Baobab, right? From like modeling and sort of setting up assets through rigging and animation, getting it into Unity, doing all of our interactions, and ultimately like even rendering it out for our like pre-rendered experiences for like Gear VR and Daydream platforms. And so like having all of that knowledge is, by necessity, I'm a little higher level than I used to be, I guess, right? But it also gives me a great opportunity to jump in and help like wherever things are necessary, and also to sort of act as like sort of the advisor who can like help at all these steps and help let people know that like what they're working on is going to fit in well with the rest of the pipeline. And then it also involves lots of bidding and scoping and making sure that our grand ambitions are possible with our relatively small team. So.
Actually, I don't think I asked you this before. Had you used Unity before you moved into VR?
No, not at all.
Okay,
and in fact,
so
our first project was all done in Unreal even.
Oh,
and
right.
So for Asteroids, we switched to Unity. And so.
Wise choice.
What?
Wise choice.
Definitely. 2 thumbs up. But I'm not just saying that because I'm here. It's really been a great experience working with Unity.
So you went over some of the technical challenges for Rainbow Crow. Like, that was fascinating, and personally, I would love to see you guys just release that the noise shader as like a crazy standalone on VR or like on Steam. That would be awesome. But can you talk a little bit about technical challenges or pipeline changes that you made going from Invasion to Rainbow Crow, or through Rainbow Crow, I guess, because you had another one as well. So
yeah, so the biggest technical pipeline change was actually switching from Unreal to Unity. That was very large. I'd say that going from Asteroids to Rainbow Crow, though, a lot of our pipeline changes were about trying to set it up so it was easier for lots of people to work in the same environment. So I think that what we're doing is a little different from like a lot of games where you might have like lots of separate levels that different people are working on, right? And what we really have is one level, right? Like we're this one continuous playthrough experience, but where we have this like whole team of people all trying to work in there at once to achieve that visual look, right? And so there are different ways to get lots of people working in the same environment, but none of them are super clean. And so we actually have a lot of internal pipeline built up around trying to refine that process. And so, like I know one thing that's commonly used is like a lot of prefabs, like a prefab per person. But we really like using prefabs like as like little pieces that we can like duplicate, right? Like you saw all those green bushes, right? Like we want a green bush prefab. And so we actually use multiple scenes per person, which has worked, or not multiple scenes per person, but multiple scenes all glued together to create one major scene, like one scene per department, say. But that's worked pretty well, but especially like getting it to work really nicely with timeline and have different timelines per person. And it's just been a lot of sort of infrastructure around making that work really smoothly.
Do you have a good example? This is really fascinating. The separate scenes thing. Like, would the art team have a different scene than the VFX team, I guess?
Yeah, absolutely. So we have
Okay.
like a lighting scene and a VFX scene and an animation scene. So each department basically has its own scene that it can work within, right? And that lets us really cut down on like file contention and on merging like conflicts, which is great. But the Unity support for multi-scene workflow can be a little iffy because like bindings within a scene work great, but bindings across scenes don't work so great, or at all. So, and so we have to sort of like reestablish all these cross-scene bindings together.
Yeah, that is really interesting.
So.
We should talk more about that later. So when we were talking before, you mentioned that working at Baobab, you're now working with both game people and cinematic folks, people from both backgrounds. So I was curious to talk a little bit more about how you all ended up working together, and also does it end up being the game folks that focus more on the interactive elements, or the cinema folks really eager to jump into that too? Like, how do y'all make that work?
Yeah. So, I mean, I think that. Like, it's really an interesting environment at Baobab, and I assume most places doing sort of similar problems, right? Because this isn't something that like they're already experts in, right? Like, this is a brand new thing, and so there's like a lot of aspects that are like film, right? Where you're telling the story, and you want like really good pacing and timing, and super high quality visuals. And so there's a lot of people at Baobab from the film side, especially from DreamWorks, like I mentioned. But we're not just making a film, right? We don't want this to be a film, and it shouldn't be a film, because that would not be a good experience to just sit in VR and like passively watch this thing play out in front of you. And so literally like right from the beginning, like we knew that we had to bring in people from both sides, right? So we have a lot of people from the film side, but also a lot of people from the games industry, right? And I think it makes for a really interesting environment, because both sides are sort of used to working like the way that they are. Like they're used to, right? And we're creating this new thing, but no one even quite knows what it is. And so it's really valuable to have those two viewpoints, right? Sort of each sort of pulling their own way in terms of like how important interaction is and how important, character deformations are, right? And I think, ultimately, we get onto the same page to sort of create this product, right? But the way we figure out even like what we want to create is that like interplay between the two viewpoints. But that being said, I think that in terms of like what people work on, like now we are all making these experiences, right? So it's not like within the company there's like, oh, these are the games people, they do the interactions, these are the film people, they do Maya stuff. Like on the engineering side, like everybody is working on everything. I mean, certainly like like the animators, they're basically doing animation, right? And in narrative storytelling, we have like a lot of just straightforward animations, not a lot of cycles, and so their workflow is probably more like typical film, I would say, right? But sort of once you get past doing the animation, we're really like trying to like integrate everybody to create this new thing.
Do you ever test out really extreme versions of interaction and then scale it back, or do you kind of know going in when you start production, is it all storyboarded out and you already know how far you want to go?
I mean, in terms of interaction, like we are always trying things, right? And like half the time, we try something that we don't even think is extreme, right? And we get it in there, and it doesn't work at all, right? So like on Asteroids, you have the ship. But especially like if you're not in like a room scale sort of VR setup, like you need a way to move around the inside of the spaceship, right? And the first thing we tried was like sort of your classic teleport mechanic, right? You got your little parabolic arc and you sort of shoot it out and it lands and you teleport there. And it's a fun mechanic and it works great normally. But a lot of our audience is at film festivals and stuff like that where people are relatively new to VR. And also teleporting is just kind of fun. And so people would literally sit there teleporting around the ship instead of watching the story. Yeah. And so in that sense, like the interaction was good. Like we had a good teleport mechanic, but it didn't serve the narrative, right? It just served to like distract from what was actually happening. And so we ended up with like a much simpler movement mechanic where you just like hit a button and blink forward in space just a little bit, which for a total like VR, like someone like going into VR for the first time is simpler, which is good, and it also sort of prevents you from like disengaging with the story by having like this really fancy interaction.
You know, it's interesting you mentioned that for the tools that we work on and my team, they tend to be like about as complicated and featureful as anything you'd ever use in VR because we're trying to make pro tools. And the things I realize is that having someone who is new to VR try out this experience is basically useless because we're trying to build on standards that exist. So if you're using blink locomotion, which I think is like a fairly standard thing now in VR, many experiences have it. It came out several years ago. Anybody in the industry knows what you mean when you say blink locomotion. It's weird that we're still exist in this world where we've got standards for everyone in the industry, but then you've got newbies who are trying it out and are like, whoa, this is so cool. And you're like, look at the rabbit, guys. Look at the rabbit. So, yeah, you're not alone. It'll change. But, yeah, it's a really weird time to be creating content right now.
And even those standards are changing, right? Like, you look at what was normal for movement like a year ago. It's different from what it is now. Totally. And I wouldn't say that, like, a year in the future, it's still going to be this, right? So, like, even amongst really experienced VR users, it's kind of like a moving target in terms of, like what is natural and what is sort of novel and strange.
And from medium to medium, right? And, you know, maybe it's a standard in one game, and it's got one button pairing, and then you switch platforms or switch games, and it's another button. Same thing, but different button. Yeah. So to that end, we know that everything to development in VR takes way longer than in conventional 2D animation or 2D, 3D, where we kind of have it nailed down. So my question is, how much longer does it take?
I don't know. I mean, coming from DreamWorks, it doesn't seem like it takes that much longer because, like at DreamWorks, we'd spend like a month just rigging like a character's toes who had like shoes on the whole time, right? So, I mean, like, I think that by being small and nimble and smart, you can actually like cut the right corners, right, and trim down on production costs compared to like these huge giant companies. But that being said, I think that because so much of what we're doing is new, like, it's not necessarily that it takes longer all the time, but it's more uncertain, right? Like with something like film, right? Like you can schedule it out really well, and you basically know how long each step is going to take. But then when we're talking about something like interactivity, like we don't know how long it's going to take to come up with a really good movement mechanic, right? Like we can try one and we can prototype a bunch, but you know, ultimately, it's a little bit more experimental and discovery-based. So as opposed to just like taking like something we know how to do and just executing on it, like a lot of what we're doing now is figuring things out for the first time. And so, like sometimes it takes a long time, and sometimes we just do something right away, and it's just right out of the gate great, right? And it's like a fantastic surprise. But it's really that uncertainty, right? Like I feel like the variance in terms of how long things take is what's really like super high now.
Sure. You never know what you're going to get until you get in the headset. Are there things that you've learned on the last few pieces that you didn't end up using, like the blink locomotion, for example, that you're kind of sidelining, thinking that it might be something you could do in the future? Or is it sort of, do you want to create your own sort of standards of interactions within the Baobab ecosystem?
I mean, that's a good question. I mean, I think to a certain extent, like, we want to create those standards within our ecosystem, and that like we want, you know, all of our pieces to hold together, and for people who are real fans of Baobab to be able to jump into a piece and sort of understand how it works, right? But that being said, like we're making like these experiences for like the mass market, and so we're not going to like ignore like the prevailing like interaction schemes, right? Because we want like everyone to be able to use them and enjoy it. I mean, in terms of stuff we've learned previously, like I'd say that I mean, we try not to get too far down the path of anything before we decide if it's going to work or not, right? And so, like things like the teleport, we actually had gotten really far because it was really fun. It was good, right? But you know, we ultimately decided it didn't work well. But I think that was pretty early on in our process of developing this interactivity. And as we've refined our process, and I'm sure this is old news to people in games, but we do a much better job of like prototyping and doing like really rough versions first and trying to decide if it's really going to work. And early on we didn't do as good of a job of that. And so I think we have fewer of these like things already done in great shape, just sort of ready to drop in at a moment's notice, because we try to kill them off if we're not going to use them, so we don't waste a lot of time on them.
Yeah, go quick and dirty at first, right? That totally makes sense. Let's see, were there any, this is taking a step back again, moving from the cinematic to virtual reality, what were the biggest like pain points or surprises that you didn't expect?
I'd say that this wasn't totally unexpected, but you don't always think about it. But in like filmmaking, everything is cheated, right? Like you cheat constantly. Like characters aren't really looking at each other. They're sort of like just looking into that, like on screen they look good, you know. You have like a character like put their arm around a character, and like their arm is actually stretched like 3 times its normal length to fit, but it's off screen, so you don't really see it, right? And then in something like VR, where you know it's this immersive environment that the user can like move around in, like all of these cheats like are way harder, and you know you can get away with some of them a little bit, but so much more you need to make things that like actually work in the real world, right? And I mean, I think it's interesting, even going from like 2D animation to 3D animation, you have some of these same problems, right? With like the classic example, like the Mickey Mouse ears, you know, that are always oriented towards the screen, right? And then you get like a 3D Mickey and he always looks a little weird because it's hard to do that. It's like that same sort of problem just brought like into virtual reality, and like as we make our mediums have more and more fidelity to real life, like cheating gets harder and harder, so.
That's interesting because the current crop of tools for traditional media really let you cheat a lot and let the director be very precise in a way that you couldn't do back in the day when it was all human actors that were stage people from the 20s. So yeah, I'm curious to see if we'll see directors kind of let go again and go back into the nitty gritty, or if it's we're just gonna come up with better cheats. We'll see.
Probably a combination of the two, because I'm sure that we are cheating things in places where we can get away with it, right? Or saying, well, let's make sure the viewer's over here, because then all the staging works out really nicely. So.
Sure. So I have one final question before we open it up. So we talked a lot about VR and narrative in VR versus interaction. So what I'd like to ask you about is augmented reality, where you have even less control over what the viewer sees and does. Do you think this type of narrative can work with that?
I mean, I think it can, right? Like I am personally, I think augmented reality is super cool, right? As soon as AR Kit came out, I used it as an excuse to go buy myself a new iPad so I could start playing with it. And so, I think that some of the tools we talked about, won't work in AR. They're really VR specific, right? And it depends on how you do the AR, right? But like a character who really comes up to you and is your scale is trickier in AR. So much more frequent in AR, you have a smaller environment, right?
Yeah, like a big scary bunny coming up to you.
Yeah, or those aliens towering over you like this, right? And so I think some of the cheats may not cheats, but some of the techniques may not work. But I think in terms of telling a story, there's no reason why storytelling is restricted to VR any more than 3D, right? And I think absolutely you could tell a really great story in AR. And I think a lot of the VR tools will be useful, but I think you're going to need new tools for AR just like you need new tools for VR, right? And new techniques to make sure that the viewer's really enjoying the experience.
Sweet. I look forward to seeing Rainbow Crow on Magic Leap next year, hopefully. All right, we're going to open it up to some questions from the audience. So I guess if you raise your hand, I can come and bring the mic to you. Actually, there's a mic right there. There you go. Okay.
Thank you for sharing your journey and experience. It's very exciting and inspiration to learn. I'm curious about whether there's a new development or a new way to develop the story. Say traditional storyboard is kind of like 2D flat, but it doesn't necessarily represent how to design the other side of blind spots. So just wondering, if there is a new methodology from developing storyboard-wise versus whether there's an advantage designing things in true VR space. Thank you.
Yeah, that's something that we talk a lot about. Our process still begins very much like a normal story process with a script and 2D storyboards. but it doesn't work nearly as well like in terms of understanding what it's really going to be like. Like a storyboard gives you a pretty decent idea for film, but it takes even more imagination to think about what that's going to look like in VR, like especially with interactivity going on. And so, I mean, we are always exploring ways to like get stuff into VR as early as possible, right? Because I think the earlier you can see it like in the right medium, like the better you're going to understand if that story is working or not. So, like our process begins still with storyboards, but like we try to get out of there as quickly as we can and get into like being able to see something in VR. So that's how we've addressed it so far.
Actually, something we're tackling next year.
Oh, good.
Hi, so I was wondering if you might be able to get a little bit more detail on the type of interactivity that you're doing in the short films that you're making, because I think that there's a very interesting blend between cinema and the kind of the passive viewing experience, and then also interactivity, whether that's not just eye look direction and trying to draw the viewer's attention to certain directions, but also is it more than just like moving around the scene that you were having experimenting with or that you're seeing moving forward?
Yeah, so there are absolutely tons of different ways to interactivity, and I think we're still sort of experimenting with what makes the best sort of interactivity in like one of these narrative experiences. And it may be that like the sort of interactivity you choose is relates to the kind of experience you want people to have, right? So you might use it as a tool, you know, just like lighting or something like that, or music, right? I'd say that, you know, like all of our experiences have these places where the characters sort of interact with you, and we're trying to almost do it subtly, right, to sort of make the character feel real, right? But in something like Asteroids, you're really like a character in the scene. You have arms, you have, you know, the characters ask you to do things, and you can interact with the world and like trigger things to happen in the story, right? And it's challenging in terms of like keeping the narrative moving along, right? Like we still need to make sure that like if you are not doing things, that the characters react appropriately and like, you know, shove you out of the way and do it themselves maybe, right? Like we need to make sure that the story goes on, right? But there, you know, it's sort of a chance for you to be more of a active participant, even if you're not like maybe like the star of the show, you're still like a participant in the world, right? And then there's also just like little like subtle like interactions you can do with like the world, say maybe, right? So that like maybe you're not directly influencing the story, but at least like you can see that you have an impact on the world around you, right? And that can also help with like the immersion, and without necessarily needing to like work out more complicated ways to keep the story like really focused and on track, right? Just letting you touch and interact with the things around you can really make you feel like you're there as opposed to just like a ghost or something.
I apologize if this had been addressed because I got in here a little bit late, but I just had a sort of a spectrum between cinema and video games, and that it was kind of like not really on that spectrum. Immersive theater. And I know you know what I'm talking about because I saw you at the Speakeasy, what, about 8 months ago or so. And have you heard of this, the Speakeasy?
I've not heard of the Speakeasy, but immersive theater is definitely, I think, a really interesting way to think about VR. And I think in some ways, maybe like one of the most accurate like analogs, I guess, right? Because you do have these characters, they're trying to act out a story, right? But you are there and all around, like, and it's taking place around you, right? And so, yeah, we've definitely sort of discussed like techniques that are successful there and trying to integrate those more and more into our experiences. But I totally agree. Like it's really, I think, an interesting analog.
Yeah, I talked to the director about that, and I don't know if it was DreamWorks or Pixar or both, but I know Disney as well have like grilled this guy on like, how did you do that, right? So it's like he's got three-act plays that are interwoven across 3 major stages and 4 minor stages and so forth, and you can walk around. It's like being in VR in reality. And I thought that was like, it was an epiphany for me as a way to design VR experiences. It's really not about how do I tell a story like I would in a movie. It's really how do I immerse people like I would in a theater. So it was just, I wanted your opinions on that.
Yeah, no, I totally agree. I think that's a really interesting way to think about VR storytelling.
Just to add to that very quickly, since we were at the same experience, I was just talking with Edward Sachi, who runs Fable Studio, there formerly Oculus Story Studio, and he was like, "Oh, interactivity. You know, people always just want to break stuff. Like that's the first thing you want to do if you give them interactivity." So when I was at the Speakeasy, I actually went out of my way to steal some chips from the gambling area, which I've never done before, would never do in a real casino, but it was super fun and I got away with it. So when you give people activity, they will break it.
Right, and to your point about like when people first get into an experience, they start teleporting, they explore. So this is the nice thing about the speakeasy. You get there a half an hour before the story begins. You get to explore. So I think those are the kind of things we have to build into our narratives is time to acclimate and let people do what they want.
Yep, that's totally true.
Thank you.
Coming from a film animation background, I'm actually just curious if you can elaborate a little more on where you guys netted out on the character deformations, like a couple dozen face shapes and a whole bunch of correctives, or where was the line found for that?
So it was found very heavily on the character animation quality side. And so we've actually put, apart from sort of our pipeline improvements like I talked about, one of the other areas that we're constantly pushing on technologically is ways to get better and better like quality animation like out of Maya and into game engines. And so we have a sort of an internal proprietary like pipeline for doing that, but it lets us get like much higher quality animation out of Maya than you typically would with like an FBX export or something like that.
Actually, maybe on a related note, is there anything on the roadmap for Alembic support? I know it's supported in Unreal. That was one of the. Maybe I'll ask the tech guys downstairs.
There is like I think like Unity Japan put out like a Alembic plugin.
Yeah, they did.
Okay.
Yeah, our roadmap is public right now. I couldn't tell you for sure when it is coming out, but yeah, we can check on the website.
That would just be a game changer. So cool. Thank you.
Hi, yeah. So coming from a putting game tech in animation studios kind of perspective, can you talk a bit about how you got your traditional pipeline, so your Maya artists doing your modeling and animation, getting them to work in the pipeline, which is more of a gaming environment where you have multi-scenes and you have different types of project management. How did the pipeline look? I mean, how did you resolve what you would normally do on a Maya side, where you're probably using Shotgun to do publishing, whereas on a gaming side, where you've got scenes and prefabs and a whole different set?
So on the animation side, our process looks pretty similar to I think like what you typically see like in an animation studio, right? Like we have like these ridiculously long shots, but they're still essentially a shot, right? And they're assigned to an animator, and they work in Maya, and do 2D play blast and that kind of stuff like they normally do, right? But I think where it is different is that we've tried to really accelerate as much as we can, like the time to get data out of Maya into Unity, right? And so, I mean, part of the benefit of having like our own character pipeline, right, is that we can control it really well, right? And so when we're getting data out of Maya into Unity, like we have a lot of control over that because it's all sort of internal proprietary technology. And so we try to do that very quickly. But like in terms of our animation team, like they work more like you would in like a classical animated film, right? It's just in reviewing their work and in analyzing it, like we have to do that in VR as opposed to just in 2D, right? But their actual process isn't like dramatically different, I guess.
So are they reviewing in VR? I mean, are they pushing the animation over the fence to somebody else who validates, or are they actually at their desks being able to try out to see what they've done and does it work or not?
So they can at their desks try it out and see if it works, like in Unity, right?
Okay.
So we just try and accelerate like that process as much as we can. But we do reviews in 2D too, because there are advantages to doing like face-to-face, just like sit at a screen, like watch Eric's actual like facial director performance, like conveying what he wants to have happen, right? And then like also in the headsets, you can really understand what it looks like in VR. Like I think there's really benefits to both types of reviews, and so we try to do both.
Okay, all right, thank you.
All right, I think that's all we have time for. So if you have more questions, though, I'll happily stick around after and answer them. But thank you very much for coming and listening to all the stuff we've done. And thank you, Tim and Exosil, for all your help.